We live in a world obsessed with shortcuts, supplements, powders, fads that promise muscle overnight. But nature has already gifted us with something profoundly powerful, something simple, something often ignored. A mineral. One that works silently behind the scenes, orchestrating countless reactions in your body, fueling muscle growth, optimizing energy, reducing inflammation, and even sharpening your mind. When we talk about muscle growth, the conversation often begins and ends with protein, training intensity, rest, or perhaps testosterone. But there's something far more foundational, something that sits quietly behind the scenes, orchestrating the very chemistry of performance and recovery. And that something is the presence of a mineral involved in more than 300 enzymatic reactions within the human body. This is not a supplement trend or a health fad, it's basic human biochemistry. Imagine every cell in your body functioning like a factory. Inside these microscopic factories, countless operations occur every second, producing energy, repairing damage, creating new proteins, and transmitting signals. These aren't random processes, they require coordination, and above all, they require catalysts. Enzymes act as those catalysts, but those enzymes often require a cofactor to even work. That's where this mineral steps in, activating hundreds of enzymatic functions across every major system in the body. Think about muscle contraction for a moment. When you perform a curl, squat, or deadlift, your muscle fibers are firing in response to electrical signals. Calcium is being released in ATP. The energy currency of the body is being consumed. All of these processes depend on enzymatic actions, and those enzymes depend on this single mineral to function. Without it, your muscles don't contract effectively. Your nerves don't fire accurately. Your energy production stalls. Recovery slows. Growth halts. Now consider what happens inside the mitochondria, the powerhouse of your cells. The conversion of nutrients from your food into usable energy is a series of chemical steps, a biochemical dance, if you will. But many of those steps only proceed if this mineral is present. Without it, the entire energy system begins to sputter like a machine running low on oil. That's not just fatigue you feel after a workout. That could be a deep-rooted inefficiency caused by a deficiency you never knew you had. It's also important to understand how this mineral regulates electrolyte balance, nerve conduction, and even the rhythm of your heart. During intense physical activity, your body loses electrolytes through sweat. If you're already low on this mineral and continue to deplete it, muscle cramps, irregular heartbeat, or even neurological symptoms can manifest. But in the right levels, it promotes relaxation of muscles post-contraction and helps prevent excessive inflammation after training. This is not an isolated function. The body doesn't compartmentalize health the way we tend to in conversation. Everything is connected. Energy, sleep, stress regulation, muscle repair, all are influenced by this mineral's availability. And because so many enzymes rely on it to function properly, its absence creates a ripple effect, subtle at first, but eventually significant. The unfortunate reality is that despite its importance, a majority of the population doesn't get enough of it. Whether through poor soil quality, processed diets, or chronic stress, depleting reserves, we often find ourselves running on low, even when we think we're doing everything right. Correcting this imbalance doesn't just improve one aspect of health. It unlocks a cascade of improvements across the board, particularly when it comes to building muscle efficiently, sustainably, and naturally. When muscles are pushed to their limits through resistance training, high-intensity workouts, or even daily physical stress, tiny microtears form within the muscle fibers. This isn't a sign of damage in the destructive sense, it's a necessary trigger for growth. The body responds to these microtears with a finely tuned repair system designed not only to heal the tissue, but to make it stronger than before. At the heart of this repair system is a biological process called protein synthesis. And one of the key regulators of that process is a mineral often overlooked, magnesium. Protein synthesis is the mechanism through which the body builds new muscle tissue. It involves translating genetic instructions into proteins, which are then assembled into the muscle structures that give strength and endurance. For this process to occur smoothly, a series of enzymes must be activated at precise times and in precise ways. Magnesium acts as a necessary cofactor for these enzymes. Without it, protein synthesis slows dramatically, regardless of how much protein is consumed through diet or supplementation. In fact, a deficiency in this mineral could render high-protein diets far less effective, because the machinery required to build muscle isn't functioning at full capacity. Beyond its direct role in muscle building enzymes, magnesium also modulates the body's stress response, particularly cortisol, the hormone that, when elevated for too long, can actually break down muscle tissue. After intense training, cortisol naturally rises, and that's part of the process. But persistent stress without adequate magnesium can shift the body from a state of muscle building to one of muscle breakdown. In this way, magnesium doesn't just build muscle, it protects it. Recovery is not just about what happens during sleep, it's about the biochemical conditions your body is in during the hours after training. Magnesium supports the synthesis of glutathione, a master antioxidant, which reduces oxidative stress and inflammation caused by intense physical exertion. Reduced inflammation allows for quicker muscle repair and less soreness. This means faster turnaround between workouts and more consistent gains over time. Another critical point is the interaction between magnesium and the nervous system. Muscle repair and growth aren't just mechanical, they're neurochemical. Magnesium helps regulate neuromuscular signals, ensuring that your muscles receive clear instructions from the brain and spinal cord. This coordination is essential not only during the workout itself, but also during the recovery phase, when muscles are rebuilding their strength and memory for the next session. What often goes unnoticed is that recovery is where the real transformation happens. Not during the workout, but in the hours and days that follow. And in that space, magnesium plays a pivotal role. It supports anabolic hormone balance, reduces catabolic stress responses, and ensures the enzymatic machinery required for repair and growth is fully operational. When magnesium levels are optimized, recovery becomes more efficient, muscle synthesis becomes more effective, and the progress you're chasing starts to appear not just in theory, but in real, measurable strength and size. At the core of every movement, every contraction of muscle, every heartbeat, and every breath lies a molecule known as ATP, adenosine triphosphate. It is the energy currency of the body, the fuel that powers all biological activity. Without ATP, life as we know it ceases. But ATP on its own is not enough. For it to be biologically active and usable by cells, it must be bound to a specific mineral. That mineral is magnesium. And this relationship is not optional, it is essential. ATP does not function alone. In fact, in the human body, ATP almost always exists in a bound form called MgATP. This means that every time your body uses energy, it's relying on magnesium to activate it. From contracting a bicep to sending a nerve impulse to triggering hormonal cascades, every function that requires energy is dependent on the availability of magnesium to make that energy usable. Without magnesium, ATP remains inert. This means that even if the body is producing energy, it's essentially locked away, unavailable for use until magnesium binds to it. In the context of muscle growth, this has profound implications. Every phase of training, whether it's the explosive effort in the gym or the quiet regeneration during sleep, demands ATP. The act of lifting a weight, holding a contraction, and stabilizing the core all draw directly on ATP stores. But if magnesium is insufficient, muscles fatigue more quickly, recovery slows down, and performance plateaus. This isn't just about physical exhaustion, it's about cellular energy not being properly activated. During exercise, the demand for ATP skyrockets. Muscle cells go through thousands of ATP molecules in seconds. The replenishment of these molecules through cellular respiration must happen efficiently and continuously. That process is again dependent on magnesium, not just for activation, but also for maintaining the enzymes that produce ATP within the mitochondria. If magnesium is lacking, the enzymes slow down, ATP production falters, and energy output diminishes. The result? Early fatigue, poor endurance, and slower muscle response. Even post-exercise, magnesium remains crucial. ATP is required to rebuild tissue, to power cellular repair, to reset ionic balances in cells, and to modulate inflammation. Recovery isn't passive. It's an energy-intensive process, and without magnesium, the body struggles to mobilize its resources. Another layer often missed is the role magnesium plays in electrolyte balance. Energy usage in muscles also involves the regulation of calcium, potassium, and sodium. These ions must move in and out of muscle cells in a carefully controlled way to trigger contraction and relaxation. Magnesium helps regulate these movements. When deficient, that regulation is impaired, leading to muscle cramps, twitching, and irregular contraction, further limiting the ability to train effectively. Energy is at the heart of everything the body does. But energy without activation is just potential. Magnesium is the spark that lights the engine. It's not optional, it's foundational. And for those seeking to grow stronger, perform better, and recover faster, understanding and supporting this mineral's role is non-negotiable. Muscle growth is not only about the stress applied during resistance training, but also about the internal hormonal environment that governs how the body responds to that stress. Among the most critical hormones involved in this process are insulin and testosterone. Both serve anabolic functions, meaning they promote tissue building, including the growth of muscle, and both are directly influenced by the presence and regulation of magnesium in the body. This mineral is not just passively involved, it plays an active, regulatory role in ensuring these hormones function optimally. Insulin is known primarily for its role in blood sugar regulation, but its role in muscle development is just as significant. Insulin acts like a key, unlocking the door that allows nutrients, particularly glucose and amino acids, to enter muscle cells. These nutrients are then used to repair and build muscle fibers. But this process depends heavily on insulin sensitivity. The more sensitive your cells are to insulin, the more efficiently they can take up nutrients. Magnesium enhances insulin sensitivity, meaning it helps the cells respond better to the hormone, improving nutrient delivery to muscles. When magnesium is deficient, insulin resistance can develop, and that efficiency is lost. The body may still produce insulin, but the cells won't respond properly, and the nutrients won't be delivered effectively to the tissues that need them most, like muscle. Now, consider testosterone, the primary male sex hormone, but also a crucial anabolic hormone for both men and women. Testosterone stimulates protein synthesis, supports the development of muscle mass, and enhances strength. Research has shown that adequate levels of magnesium are associated with higher levels of free and total testosterone. In fact, individuals who are physically active and consume sufficient magnesium often exhibit improved testosterone levels compared to those who are sedentary or magnesium deficient. This connection is not incidental. Magnesium appears to impact the bioavailability of testosterone, possibly by influencing the binding of the hormone to proteins like HBG sex hormone binding globulin, thereby increasing the amount of free testosterone available to muscle tissue. In a training context, this is vital. Muscle growth isn't just about what happens mechanically. It's about what the body is hormonally primed to do with that stimulus. A well-balanced hormonal profile, supported by magnesium, leads to greater gains, faster recovery, and more sustainable progress. Without magnesium, these hormones are less effective, and the anabolic signals that promote growth are weakened. There's also the consideration of cortisol, the body's primary stress hormone. While short bursts of cortisol are necessary, chronic elevation can be catabolic, meaning it breaks down muscle tissue. Magnesium helps regulate the body's stress response and keeps cortisol in check, maintaining a more favorable balance between building and breakdown. What this shows is that magnesium isn't just a recovery mineral or a sleep aid. It's an integral part of the body's endocrine system. It supports the hormones that promote growth, modulates those that cause breakdown, and helps establish an internal environment where muscle can be built consistently, effectively, and naturally. One of the most overlooked obstacles in the pursuit of muscle growth and peak physical performance is not poor training or inadequate protein intake. It's silent nutrient deficiency, specifically a widespread, underdiagnosed deficiency of magnesium. Up to 70% of individuals are not meeting the recommended daily intake of this critical mineral, and many are entirely unaware of it. The consequences are not always immediate or dramatic, which makes it easy to ignore. But over time, this deficiency quietly erodes performance, slows down recovery, limits hormonal efficiency, and creates an environment in the body that is far from optimal for building muscle. The body is a highly adaptive system. It does not always signal deficiencies with clear symptoms. Instead, it often compensates, redirecting resources, altering metabolic pathways, and prioritizing survival over growth. In the case of magnesium deficiency, the body might divert the mineral from muscles and bones to more essential processes, like maintaining heart rhythm or nerve function. This ensures immediate survival, but the cost is paid in less obvious ways: chronic fatigue, muscle cramps, slower recovery, poor sleep, and elevated stress responses. In individuals who train consistently and push their bodies through intense workouts, the demand for magnesium is even higher. Physical exertion depletes magnesium through sweat and increases its utilization for recovery and energy metabolism. Without proper replenishment, the gap between what the body needs and what it receives continues to widen. And because the signs are subtle, maybe just a little more soreness than usual or a bit more fatigue, most people don't trace it back to magnesium. They might train harder, eat more protein, or increase their supplementation without ever addressing the core imbalance. The deficiency also affects the way muscles function on a cellular level. Low magnesium impairs calcium regulation in muscle cells, which can lead to frequent cramping, tightness, and poor contraction quality. Nerve signaling becomes less efficient, and muscles may not respond to training stimuli with the same level of coordination or strength. It creates a situation where the input, the effort in the gym, is not matched by the expected output in muscle gain and performance. Magnesium deficiency also disrupts sleep architecture, particularly the deep, restorative stages of sleep. Since much of muscle repair and growth occurs during deep sleep, this interference adds another layer of difficulty for those trying to make progress. The stress hormone cortisol, when unchecked, becomes elevated under conditions of magnesium deficiency, further inhibiting recovery and pushing the body into a catabolic muscle wasting state. What's striking is how preventable this is. Magnesium is widely available in foods like leafy greens, seeds, legumes, and whole grains. And when dietary intake isn't enough, well-absorbed forms of supplemental magnesium can close the gap. But awareness is the first step. Many people are operating at a constant disadvantage, unknowingly limiting their potential due to something entirely correctable. Addressing magnesium deficiency isn't just a small dietary tweak. It's a foundational correction, one that can shift the body from a state of struggle to a state of growth, resilience, and balance. And once corrected, the difference isn't subtle. It's felt in energy, strength, recovery, and performance. The body doesn't grow stronger during a workout, it grows stronger during recovery. And recovery is not a passive process. It is active, demanding, and deeply biochemical. The nutrients consumed after training sessions are not just about replenishing energy or protein. They are about restoring balance, healing microtears in muscle fibers, regulating inflammation, and preparing the body for future stress. Magnesium plays a central role in this recovery cycle, and one of its greatest advantages is how accessible it is, both through diet and supplementation. Yet its potential is often underestimated, even though optimizing it can unlock measurable improvements in muscular performance, growth, and resilience. Magnesium is abundant in natural foods, particularly those that are minimally processed. Leafy green vegetables such as spinach and kale are excellent sources. So are seeds like pumpkin and chia, nuts like almonds and cashews, and legumes such as black beans and lentils. Even foods like dark chocolate and whole grains contribute significantly. But modern dietary patterns, often dominated by processed, refined items, leave these essential sources underrepresented in the average daily intake. The result is a slow erosion of magnesium stores over time, stores that are especially important for those who train hard, sleep little, or experience frequent stress. When dietary intake falls short, supplementation can be both safe and effective. But not all forms of magnesium are equal in terms of absorption. Forms like magnesium glycinate, citrate, and malate are well tolerated and efficiently absorbed by the body. They can support everything from sleep to muscular recovery to mood stability. Poorly absorbed forms, on the other hand, often pass through the digestive system with minimal benefit and sometimes with unpleasant side effects like cramping or loose stools. So choosing the right form matters. One of the most profound benefits of magnesium optimization is its effect on sleep quality. Deep sleep is when growth hormone is released at its highest levels, a hormone critical for tissue repair and muscle development. Magnesium helps regulate neurotransmitters such as GBA, promoting deeper, more restorative sleep. It doesn't just help you fall asleep faster. It improves the quality of the sleep itself, which in turn enhances how well the body recovers, repairs, and rebuilds muscle tissue. On a muscular level, adequate magnesium supports reduced inflammation post-exercise, faster clearance of lactic acid, and improved insulin sensitivity. This creates a metabolic environment where the nutrients consumed, especially amino acids and glucose, are efficiently directed toward rebuilding and fueling muscle. Over time, this efficient nutrient partitioning can mean the difference between stagnation and growth, between burnout and steady progress. It's easy to overlook something as small as a mineral, especially one that doesn't produce immediate, stimulant-like effects. But magnesium's influence is broad and deeply embedded in the systems that govern performance and recovery. Incorporating it regularly through whole foods and, when needed, through intelligent supplementation isn't a luxury. It's a necessity for the individual looking to build not just muscle, but long-term strength and health. This single adjustment can become the quiet catalyst for real transformation.